So, hello, a very good afternoon to all, and welcome to my class. Today we are going to start solution, right? Okay, good afternoon, everyone. Okay, so let's join the class, and today we are going to start. This is our first chapter, right? Solution is our first chapter of your 12th class. So, we are starting this our chemistry portion with this chapter, solution. One another chapter that is solid state. We are going to do this chapter as well. Right now, we're starting with the solution, and in this, we use the concept that we learn in our mole concept class, that is how to find the concentration of the various component like molarity, molality, and all this thing, right? So this is going to be a very interesting chapter, solution. This is the part of physical chemistry. So as the name suggests, physical chemistry, so it consists of lots of numerical for you, right? So this is totally numerical based chapter, as well as there is some very important concept present in this chapter, right? So we are going to see each and every topics in a very detailed way, right? So let's start the today's session. I'm audible to everyone, right? Okay. So if you have any problem related to the sound or the my voice, then please text me in the message. I'll definitely going to sort out, right? So let's start. First of all, what do you mean by this term solution, right? If someone asks, what is solution? Then what do you mean by this term solution, beta? Basically, solution is nothing but a homogeneous mixture of a two or more substance. This point is very much important, that is solution is a homogeneous mixture, right? So solution is a homogeneous mixture of two or more substances, right? Where in our ninth class, we studied that we classify in a three type, that is whether it is a solution, whether it is a collide, or whether it is a suspension. So we know in collide or suspension they are the heterogeneous mixture, but solution is what, beta? Homogeneous mixture. What do you mean by this term homogeneous? Can anyone explain what do you mean by this term homogeneous, beta? Homogeneous means having same composition throughout, right? So if you take the solution of water and sugar, you find the same composition throughout the liquid, right? Whether you take 1 ml of the solution or we take 100 ml of the solution, if their concentration are same, now we have then you definitely find the solution is homogeneous, means there is nothing changed. Like in heterogeneous, the composition may be varied. So homogeneous means composition remains always same. That is known as homogeneous. So first of all, this is very important point, that is solution is a homogeneous mixture of two or more substances, right? Now, a solution of two substances is called binary solution. So this one is also very important. That is a solution of two substances only. Either we take water plus sugar, or we take glucose plus water. So solution of two substances is always called binary solution. So if someone asks what is binary solution, then you can define, right? I hope is it clear to you? Now, the next is the component present in a smaller amount is called solute, and the other which is present in the larger amount is called solvent. So this is also very important, beta. How will you identify which one is solute and which one is solvent? So it's a very simple to identify. That is the component which is present in a smaller amount is called solute, and the other that is present in a larger amount is called solvent. I hope this is clear to everyone. Yes, GNP Pune, join beta till the fast. Okay, now, so this is very much clear. That is what you mean by the term solute and solvent. Let's see through example. Now, in this, we have a solute like, small substances like this. This is either be copper sulfate, or you can take any sugar, glucose, anything. And this is act as a solvent because basically anything which is present in a larger amount is known as solvent, and solute plus solvent combine together to form solution. So this one is very much important. Here solute is this and this is solvent, and this combine together to form solution. So always remember this basic rule, that is solution is made up of solute plus solvent, right? It's not necessary that solvent is always liquid. Solvent may be solid, solvent may be liquid, and solvent may be gas as well. So it is not necessary that always solvent we use as a liquid only. No, gas भी हो सकता है, solid भी हो सकता है, and liquid भी हो सकता है. Right? Basically, एक point ध्यान में रखना है. And what is this? The component that is present in a smaller amount is called solute. For example, if I'm taking two liquid, right? Liquid 1, liquid A, and liquid B. And if someone asks, beta, identify out of liquid A and liquid B, which one is solute and which one is solvent. And I'm giving one condition as well, that is liquid A is 30 ml and liquid B is 50 ml. So these two both are liquid. But out of these two also, one is solute and one is solvent. So which one is solute, beta? Liquid A or liquid B? Yes, tell me. Liquid A, liquid B, which one is solute? That is liquid A, because liquid A present in a smaller amount, right? So anything which is present in a smaller amount is known as solute, and the other that is present in a larger amount is known as solvent. I hope this is clear to you. These are the basics things you must remember, and it should be clear so that you can utilize a bigger problem or difficult problem as well. Right. Now, there's a different types of solution. As I already told you, whether a solvent may be solid, liquid, or gas. As same on the same way, solute also may be solid, liquid, or gas. So, कितने type के solutions हो सकते हैं? बहुत different types के. Like, if I'm talking about the types of solution, we have a gaseous solution, liquid solution, and solid solution. Now, what do you mean by this term gaseous solution? Gaseous solution means here solvent is nothing but gas. If I'm talking about the liquid solution, then our solvent is liquid. If I'm talking about the solid solution, then the solvent is solid. Right? So out of total, how many possibilities are there, beta? Total 9 possibilities are there. That is a solid, solid liquid, and so on. Right? But one important point here, in this chapter, we are going to discuss only this portion. Only this portion. That is liquid solution. Right. So we are going to study what happens when the gas is dissolved in liquid. This one will also play a very important role because aquatic animals survive more in cold condition as compared to the hotter condition. Right. So these type of question you really understand by knowing this concept, that is how the solubility of gas in liquid depends upon the temperature, pressure, and all. So we are going to see this gas in liquid. We are going to see this also, that is liquid in liquid. In this we are going to see the vapor pressure, Raoult's law, and lots of things. Liquid solution. And the last and the most important thing, that is when the solid dissolve in liquid. And this one you easily identify, that is glucose. We take glucose and dissolve in water. We take salt and dissolve in water. Then what behavior you observe? Whether there is a change in a boiling point of the solution, where there is a change in the freezing point of the solution, osmotic pressure. So these all are called colligative properties that we are going to study in when the solute act as a solid and the solvent act as a liquid. So this portion only, that is the liquid solution, we are going to study in this chapter. I hope this is clear. Anyone having any kind of doubt, beta? Till now? No doubt? Okay, now, so let's see the example of this, right? That is the liquid solution. When the gas dissolve in liquid, example of this, that is oxygen dissolve in water. Solid dissolve in liquid, example glucose or NaCl or carbohydrate, anything that is dissolved in a water. Gas in solid. Now, so these are the solid solution in which the gas act as a solute and solid act as a solvent. That is solution of hydrogen in a palladium. Or we say solute liquid and the solvent is gas, then amalgam of mercury with the sodium. So these are the some important types of solution, or we say different types of solution. Try to learn this one, that is liquid solution, in a detailed way, right? And just look at एक बार देख लेना बस gaseous and solid solution को. The important thing is here only liquid solution. Okay, remember what you have to remember here, beta. A solution in which water is the solvent is called aqueous solution, right? So if someone asks what is aqueous solution, so A solution in which water acts as a solvent is called an aqueous solution, whereas the solution in which any other solvent other than water, any other solvent than water is known as non-aqueous solution. So if the solvent is water, then aqueous, and any other solvent except water is known as non-aqueous solution. So this thing must be remembered. Now, the solution in which the solid is present in a larger proportion are called solid solution, right? So this type of solution in which the solid present in a larger amount is known as solid solution. Amalgam is the solution of liquid in solid. So this one is very important. That is amalgam of mercury with sodium. So amalgam is a solution of liquid in solid. Similar alloys are the solution of solid into another solid. When the solid dissolve in a solid, they form alloys. So these are the important conclusion of this table, right? So these are the different types of solution. I hope is it clear? Anyone? You can ask beta. कोई भी doubt हो किसी को जो भी समझ नहीं आया हो, you can ask. सबको clear है? Done? Okay. Now, how will you identify the concentration of the solution? This one is going to be very, very important terms, right, beta? Because this whole chapter is, just related to this concentration of the solution term, right? So concentration, what do you mean by this term concentration, beta? If you take, if you put 2 grams of salt in 100 ml of water, if someone asks, identify the concentration of the solution, it means how much gram of salt is, dissolve in such amount of water. So these type of thing is known as concentration. If someone give you a unknown solution and ask you to find the concentration, what the mass dissolve in this liquid by giving some criteria or condition, then by using this term concentration of the solution, you can actually identify the amount of solute that is present in the particular solution or not. Right. So concentration of solution means what, beta? The concentration of solution is defined as the relative amount of a solute that present in the solution. Right. So it is the relative amount. What do you mean by this term relative here? Relative means solute and solution. They are related to each other. That is, if 2 gram is present in 100 gram, if 2 gram is present in 200 gram, then their concentration vary with relative to the amount of solvent as well. So the better way to define is the concentration of the solution is defined as the relative amount of a solute present in the solution. I hope this is clear to you. Yeah. Now the next is, it is generally expressed as the amount of solute present in a unit volume of the solution. So how will you denote beta or identify the concentration of the solution? That is, it is generally expressed as the amount of solute present in a unit volume of the solution. Okay. Now the next one is, solution with the relatively low concentration are called dilute solution, right? So the solution which are relatively low concentration are called dilute solution, while those with the relatively high concentration are called concentrated solution. Right. So this thing actually you all know, I guess, right? Dilute and concentrated solution. So if the concentration is very, very low, for example, if you put, 2 gram of salt in a 1 liter of water, then obviously its concentration is very low and known as dilute solution. Now, if you put 500 gram of salt in 1 liter of water, then their concentration is very much, right? So this type of solution is known as concentrated solution. So it's very simple: dilute, concentrated. Dilute means less amount, or we say less concentration, that is 2 gram in 1 liter, where in concentrated solution we put 500 gram in 1 liter, so their amount of the solute is more as compared to dilute, right? So these are the two type of solution. I hope this is clear to everyone. Yes beta, किसी का कुछ भी सजेशन, कुछ भी पूछना हो पूछो एक बार मेरे से. सही चल रहा है सर? Should I move? So these are known as a dilute and concentrated solution. Now These are going to be very, very important. And please ध्यान से देखना बेटा इसको. How to identify? Yes, someone. Yes, sir. Okay, beta. Now the next is mass percentage, and these term is going to be very important. Why, beta? Why this is going to be very, very important? Because in this we are going to see the various way, by the various method by which we can actually identify or find out the concentration. Right? How we can find the concentration of the particular solute or particular solution by using this. So the first thing is mass percentage. So let's see, what do you mean by this term? Mass percentage. As the name suggests now, mass percentage. That is what amount of mass that is present in a particular amount, right? So what is mass percentage? So it is basically amount of solute that is present in 100 gram of the solution. Just remember this thing. Whenever mass percentage, whenever it is given like 5% of solute, it always means 5 gram of solute in 100 gram of solution. Whenever in question there is given 5% of particular solute is given, what does it mean, beta? It means 5 gram of solute out of 100 gram of solution. So you can find solvent now. How many solvent? What is the gram of solvent, beta? 95 gram, right? If someone give 80% by mass, what does it mean? 80% means 80 gram of the solute present in 100 gram of the solution. So this is the main thing through we understand mass percentage. Clear है सबको ये? What is mass percentage? कैसे mass percentage हम लोग निकालेंगे? मास परसेंटेज का मतलब ही क्या हुआ बेटा कि टोटल 100 ग्राम के सॉल्यूशन में अगर मेरे को बोला 5% है तो बोलेंगे 5 ग्राम प्रेजेंट है आउट ऑफ 100 ग्राम. 80% है मतलब 80 ग्राम प्रेजेंट है आउट ऑफ 100 ग्राम. So this is how we can find the mass percentage. I hope this is clear to you. So the formula for finding the mass percentage is mass of the solute upon mass of the solution into 100. So we can find mass percentage, right? Okay. So I hope this is clear. क्योंकि बहुत सारे ऐसे क्वेश्चन आएंगे आपके कॉलिगेटिव प्रॉपर्टीज में जहां पे सीधा गिवन होगा दैट इज 5%, 8% बाय मास. सो यू हैव टू आइडेंटिफाई दिस टर्म. 5% means what? 5%, 5 gram. That is a 5 gram of solute present in the 100 gram of the solution. So the solution is 100 gram, solute is 5 gram. So solvent become 95 gram. Okay, so this thing you must remember. Now the next is volume percentage. Similar. Here I am talking about weight by weight, right? That is mass of the solute and the mass of the solvent. Both are present in a weight. Or we can mass of the solute present in a gram, where the mass of the solution also present in a gram. Now this is known as weight by volume. Weight by volume. What does it mean, beta? Weight by volume. Weight by volume means here mass of the solute is present in a gram, where the mass of the solution is present in a volume. Mass of the solution is present in a volume. So these are these volume percentage is the most common thing that we are used in our day-to-day life, right? Just we put 2 gram of sugar in 100 ml of water, 3 gram of sugar or 3 gram of salt in 100 gram in a 100 or 150 ml of water. So these things we use on our daily basis, right? Volume percentage. So what is volume percentage? That is the volume of the solute in milliliter which is present in a 100 ml of the solute is called volume percentage. So actually this is volume percentage, right? Solute is also in volume and solvent is also in volume. One another is that is weight by volume. So in weight by volume, solute is present in gram, where the solution is present in volume. So one another method, that is a weight by volume. This is volume by volume. Okay, so please correct this. This is not weight by volume. This is volume by volume. So what is volume by volume percentage, beta? That is volume of the solute in milliliter upon volume of the solution in milliliter multiply by 100. If someone says this is 20% volume by volume, what does it mean? It means 20 ml of the solute that is present in 100 ml of the solution. So here solvent comes out to be 80 ml, right? So this is all about the volume percentage. Now, the next one, and this one is also very, very important, that is mole fraction. So what is this mole fraction? So let's understand mole fraction with a simple example, right? Now, for example, this is the solvent, right? This is a solvent. So let's donate the mole of the solvent through capital N. And this is solute. So we add some substance. So number of mole of solute is N. Now, if someone asks, what is mole fraction? As the name suggests, mole का fraction कि दो लोगों को मिलाया उसमें A का कितना amount है B का कितना amount है, that is called the fraction ना, कि दो को मिलाने पे दोनों का individual fraction कितना कितना आ रहा है, so that is called fraction. So what is mole fraction beta? So it is the ratio of the number of mole of one component, that is solute or solvent, to the total number of moles of solute and solvent. Is it clear? It means it is the ratio of the number of moles of one component upon me number of mole of the total number of moles Okay, so sorry, some network problems are there, right? So let's start now. So what we are discussing about, that is a mole fraction, right? So what is this mole fraction, beta? So it is basically the ratio of the number of moles of one component divided by the total number of moles, right? So for example, if someone asks you, just calculate the mole fraction of the sugar, right? So if you have to calculate the mole fraction of sugar, then what is the mole fraction of sugar, beta? Mole fraction of sugar is equal to number of moles of sugar upon number of mole of sugar plus number of mole of water, right? Because in our syllabus now we are going to discuss only about the binary solution. That is when only two components are present. That is, one is solid and one is solvent. So only two. Okay, right. So it is basically how you can identify. Similar, if someone asks how to identify the mole fraction of the solvent, right? For example, if someone asks identify the mole fraction of water, then what you have to do, beta? Mole fraction of water is also equal to number of mole of that component, means number of mole of water upon again total number of mole. So this is how you can actually identify or calculate mole fraction. So as you observe, sum of the mole fraction is always comes out to be 1. Always comes out to be 1. So always remember one thing, for a faster calculation, just do one thing. And what is this, beta? Just calculate mole fraction of the one component, and for second one subtract with minus 1. Right. For example, if I'm calculate the mole fraction of the sugar comes out to be 0.70, then there is no need to calculate the mole fraction of water through this formula, right? Just calculate mole fraction of water is 1 minus 0.70. It comes out to be 0.03, because the sum of the mole fraction is always equal to 1. Is it clear to everyone? जल्दी बता दो बेटा एक बार, सबको क्लियर है क्या? Right? You get the idea how to calculate the mole fraction? Okay. Now, this one is also very important, types, that is a parts per million. So these unit of concentration is basically we use when the solute is present in a very, very small quantity as compared to the solvent. Right. So whenever such cases arise, when the solute is very small as compared to the solvent, even you have to calculate the concentration, then you use this parts per million. It is very much similar to the mass percentage, because in mass percentage, what we calculate, beta? For example, if someone is given 50%, what does it mean? 50 gram out of 100. Someone giving 2%, 2 gram out of 100. So here, instead of out of 100, here it's become 1 million. So if someone say 2 ppm, pollution level is 2 ppm, what does it mean? It means 2 parts of that particular component out of 1 million, right? Out of 1 million, or we say 10 to power 6. So when the amount of the solute is present in a 1 million, that is, amount of solute in gram is present in 1 million, or per ml solution, the concentration of the solute is expressed in ppm, right? So in mass percentage, you observe that here 10 raised to the power 2, or we say 100 is there. But in parts per million, it will be 10 raised to the power 6. That is, you have to calculate out of million. That is how many gram or how many ml of the solute or the component present out of 1 million. So that is how you calculate parts per billion, right? Okay. In case of gases, ppm refers to volume rather than the masses. So this is important note here, beta. In case of gases, when you have to calculate the calculation for atmospheric pollution, we know want to calculate the amount of which gases component is present. So in case of gases, ppm refers to volume. Okay, ppm refers to volume rather than masses. That is 1 ppm is what? That is 1 centimeter cube of gaseous component is present in 1000 liter. This is mean by the 1 ppm, right? So this is how you can calculate this. Now, these all things, whether it is a mass percentage, whether it is a mole fraction, these all are temperature independent quantities, right? There is no effect of temperature on this mass percentage or mole fraction, because these things, mass is independent of temperature. Where in a coming concentration defining term, that is molarity, we are going to see instead of mass we use volume. So volume depends on temperature, so they are temperature dependent. But whenever the mass comes into the picture, whenever the mass of solvent is given, mass of the solution is given, mass is totally independent of the temperature. So mass percentage, mole fraction, these all are, yes beta, these all are temperature independent concentrating defining term. Now, this one is going to be very important one, that is how will you calculate the strength or concentration in gram per liter. So this is also known as the strength of the solution, or we say concentration in gram per liter. That is amount of solute which is present in a gram in a volume of the solution, that is in 1 liter of the solution. So amount of solute that is present in a 1 liter of the solution is known as gram per liter, or we say strength of the solution, right? So it represents the number of gram present in 1 liter of the solution, and this is the formula for calculating the gram per concentration in gram per liter, or we say strength, right? So this is clear. Now this one is going to be very important one, that is molarity. How will you calculate this term molarity? So this is very important one, and please try to understand this thing in an important way so that you can able to do numerical related to this molarity or molality, right? So what is molarity? First of all, molarity is represented by capital M, where molality is represented by small m. So always try to differentiate these two, right? So what is molarity, beta? So molarity is nothing but the number of mole of the solute present in the 1 liter of the solution, right? So the number of moles of the solute that is present in the 1 liter of the solution is known as molarity. So we can define molarity as number of moles of the solute divided by volume of the solution in 1 liter. Now, we all know that we can also write the formula of molarity as, we know that what is mole, beta? Mole is nothing but mass of the solute. Mole is nothing but mass of the solute divided by molar mass. So this is all about the moles, right? So this is all about the moles. So we can also write moles as mass of the solid divided by molecular mass. Now, in many questions now, volume is given in ml. So how will you convert this ml into liter? We all know, just dividing by 1000. So this is volume of the solution. Remember this thing. Here we use volume of the solution. So if the volume of the solution in milliliter, then divide this term with 1000. So this is one of the very good formula actually to do the numerical in a faster way. That is molarity. So what is the formula for finding out the molarity of the solution, beta? That is mass of the solute divided by molar mass into 1000 divided by volume of the solution in milliliter, right? So this is how you can identify the molarity. I hope this is clear to you. Yes beta, सबको clear है क्या यहाँ पे? No one, anyone having any kind of doubt? Please ask. Clear है सबको? What is molarity? Okay. Now, if in any question 3m is given, what does it mean? What does it indicate, beta? If someone says the solution is 3 capital M, what does it mean? It means the solution having molarity of 3. What does it mean, beta? That is 3 moles of the solute dissolve in 1 liter of the solution, right? So 3m means what? There's a very good meaning of this word, 3m. So 3m means 3 moles of the solute, particular solute given, whether it is a NaCl or we say glucose, anything. So 3 moles of that particular solute dissolve in 1 liter of the solution is mean by 3m, right? Similar, if someone give, okay, this solution is 0.05 molar. What does it mean, beta? It means 0.05 moles of the solute dissolve in 1 liter. So this is the significance of these things, right? Because you observe this thing in your 11th class as well, many questions, the question is like 0.05 molar of the particular solute dissolve in this to give these, right? So what do you mean by this thing? 0.05 m, 3m, 2m, 1m. It means this much of solute dissolve in 1 liter, right? So this is the important formula. Remember this. And this is the basic formula, right? That is number of moles of the solute upon the volume of the solution in liter. Now, one important note here. What is this, beta? The important note is molarity varies with the temperature. Because in this volume comes into the picture, na? I already told you, whenever the volume comes into the picture, they depends upon the temperature. Whenever the mass come into the picture, they are independent because mass of the solvent is totally independent of temperature, right? So this is how you can calculate molarity, that is capital M. Okay, so molarity varies with the temperature due to the accompanying change in the volume of the solution. So we can say that this is temperature dependent quantity. Now, what is the relationship between molarity and strength in a gram per liter? So we already know this thing, that is, what is strength in gram per liter? It means mass of the solute present in a gram divided by volume of the solution, right? So this is the formula of molarity. We know that molarity is equal to mass of the solute in gram divided by the molecular mass of the solute into volume of the solution in liter. This term, beta, this one, right? This term is known as strength in gram liter. So strength in gram liter divided by molecular mass of the solute is also known as molarity. So in some question, if the strength is given, if a strength is given in gram per liter, and if you divide this thing with the molecular mass, then you get the molarity as well. So this is the relationship between the molarity and strength in gram per liter. I hope this is clear to you. Any doubt, beta? No? Now, the next important relationship is relation between the molarity and the mole fraction of the solute. This is also very important. How will you relate molarity, which is temperature dependent, and a mole fraction, which is temperature independent, to each other? So their relation comes out to be m1 divided by m into m1 minus m2 plus d. What is m1, m2 and d here, beta? D is the density of the solution. So whenever if we have to try to relate the relation between molarity, mole fraction, or try to calculate the numerical value by using mole fraction, if you have to calculate molarity or you have to calculate mole fraction by using molarity, always density is given. Without density, you cannot proceed, right? So D is the density of the solution. M1 is what? So M1 is the molar mass of the solvent. Very important. M1 is the molar mass of the solvent. And what is M2 here, beta? M2 is molar mass of the solute. So M1 is the molar mass of the solvent and M2 is the molar mass of the solute. And what is capital M here? So M represents the molarity of the solution. So this is the relationship between molarity and mole fraction of that solute. I hope this is clear to you. Okay. Now, this is also very important because many questions comes under this topic only. What is this? This is called dilution law on the basis of molarity. What does this mean with dilution? Let us assume if you have a solution, right? If you have a particular solution and having molarity of the solution is M1 and volume of the solution is V1. Now, if you add water into this and make the solution diluted, so their molarity change, obvious molarity change, because molarity will depend number of solute per liter. So if you increase the solution solvent, then definitely molarity will change. So in this, the M1 become M2. Similar volume also change beta, it will become V2. So what formula comes out to be? The formula comes out to be M1 V1 is equal to M2 and V2. And this is known as molarity equation. This is known as what? This is known as molarity equation, right? So if N1 moles of reactant 1 react with N2 moles of reactant 2, then the formula become M1 V1 upon N1 is equal to M2 V2 upon N2. And now if the solution of the same solute, are mixed, then molarity of the resulting solution become this. That is, capital M become M1 V1 plus M2 V2 upon V1 plus V2. Because here solution of the same solute. Just remember this thing. This one is very important. If the two solution of the same solute are mixed, then the molarity of the resulting solution becomes this. M1 V1 plus M2 V2 upon V1 plus V2 divided is equal to capital. So this is all about the molarity. Okay, so in today class, what we covered so far, beta, we see what is solute and solvent. We see different types of solution as well. How many type of solution are possible? Out of these, only in this chapter we are going to study only liquid solution. Whether the liquid dissolve in liquid, solid dissolve in liquid, or gases dissolve in liquid. So these three only we are going to discuss in this chapter. After this, we saw a various concentration defining terms like mass percentage, weight by volume percentage, volume by volume percentage, mole fraction, and last but not the least, molarity. And this one is very important, right? So I hope सबको समझ आया यहाँ तक, किसी को कोई प्रॉब्लम नहीं है. जस्ट इसको सॉल्व करना बेटा. नेक्स्ट क्लास में वी आर गोइंग टू कवर मोलालिटी एंड सम न्यूमेरिकल related to this entire topic, right? So let's meet in the next class and we're going to discuss in that class that how we solve numerical related to this topic only, right? Till take care and meet in the next class.